Hi everybody, Patrick here from Engineeringshock.com, electroniclessons.com, and paintballprops.com. This is a video manual for my current Kickstarter campaign. It's ending in just a couple days. We're going to talk about the functionality of the version 1 and version 2 infrared learning board sets. Both of these boards perform in the exact same way, but the version 1 has 2 onboard relays that can control high-power devices, as well as 10 indicator LEDs that you can enable or disable. And the version 2, it doesn't have the indicator LEDs, it doesn't have the relays, but one neat thing about the version 2 is that you can control it, power it directly from your Arduino board by removing this power supply jumper. Anyhow, let's take a closer look at these boards.
This is the version 1 board. Let's start with the lower left. There are 2 power supply connectors. The primary is the DC power jack, and many of the reward tiers for the Kickstarter will include a 9-volt connector, wall adapter that plugs directly in to power the board. If you don't have a 9-volt power adapter, the secondary power supply connector is a 2-pin terminal block, and the 2 terminals are labeled V+ and ground. V+ is where you'd connect between 7 and 9 volts DC. The positive of your power supply, and the GND pin, ground, is where you would connect your power supply negative. The infrared receiver is a VS1838B, and it's very easy to connect to the board if you are working with the kit form. Of course, I will be making an assembly video, but in most cases this will come assembled and with the infrared receiver facing the bottom of the board. Of course, when you're aiming your infrared remote at the board, you want it to be facing the infrared receiver. To the right, there are 2 relays, R1 and R2. Both relays have a 3-pin terminal block, and each terminal block has the 3 pins labeled NC, CO, and NO. The CO pin in the middle is called common. It's the common pin of the relay. This is a single pole double throw relay. When the relay is not activated, it's not being driven, the CO pin is connected internal to the relay to the NC pin, which is normally closed. So when the relay turns on, the CO pin disconnects from the NC pin and connects to the NO pin, normally open. So by default, CO is connected to NC. When the relay is on, CO disconnects from NC and connects to NO, and that works for both of those relays. Those relays correspond to LED 8 and LED 9, and output 8 and 9. The indicator LED bank basically it acts to tell you when it's received a signal that corresponds to one of the outputs. We'll get to the output pins in just a second. The LED indicator bank can be enabled by placing a 2-pin jumper on the LED_EN jumper on the middle left. We'll get to those jumpers in just a second. The outputs and power connectors. This 13-pin rail has an indicator output that corresponds to the IN LED, outputs 0 through 9 that correspond to LED 0 through 9, and a regulated 5 volts VCC and an output ground GND. The output reset button. When you are in active high or active low latching modes, you can use this cell button to reset the state of all of the outputs if you wish to do this manually. You can do this with the remote if you wish, because there is an extra code that you can program in to reset all of the outputs to either all active high or all active low, or all LEDs on or off, but we'll get to that in a little bit. So that's the block diagram for version 1. This is the version 2 board. It doesn't have any of the bells and whistles. Let's talk about from the lower left again. The 5mm power supply jack. This is your main power supply, 9 volts, 7 to 9 volts DC. It's regulated down to 5 volts via IC3, which is a 78LO5 5-volt regulator. There is a power supply enable jumper called EN, which allows for you to disconnect from the regulator, and you can actually use your Arduino to power this board. Again, we'll talk about that a little bit later. The IR receiver, again, the VS1838B, is on the bottom of the board facing outwards. The output reset button is on the right, and that I've neglected to mention that actually comes into play in one of the program modes. You don't have to use it, but it's an extra function which we'll get to in a little while. The output header connector is the same as version 1. The operation of this board is the same as version 1, but again, no bells and whistles, no relays, no LED indicators. I'll show you how to make an LED indicator if you so wish to use one. Again, there is a regulated 5 volts and ground. We'll actually be using those pins to power the board from your Arduino as an option. The programming and mode select headers, these 3 headers are common to the version 1 board as well. PG is program, B is your latching / non-latching mode, jumper, and A is used only in latching mode to determine whether or not you're in active high or active low modes. So that's version 2.
First, we'll talk about the programming modes for the version 1 board. What you'll want to do is, if you're programming for the first time, and this is very important, place a jumper on the LED enable header and a jumper on the PG header.
On the top, there's a print screen of the version 1 board. On the bottom, there's a print screen of the version 2 board. We're talking about the PG jumper. The PG jumper is the program jumper. Now, this is used when we want to program in a new set of codes, or say only a couple different codes. We have that option. There's 2 methods of programming, which I'll go through right now.
Because both version 1 and version 2 operate identically, we're going to concentrate our efforts on the version 1 board, and then afterwards I'll show you how to test your version 2 board. In any case, the first thing you're going to want to do is make sure that you've got a jumper on the LED enable header right here, and you're going to want to make sure that there's a header on the PG jumper. Now you're going to make sure that there's no jumpers connecting the other headers. That's R1 for relay 1, R2, relay 2, B, and A. Make sure that your only 2 jumpers are on LED enable and PG. Now what we're going to do is, when I power it up, I'm going to program in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then let's say minus for our reset. This won't make a whole lot of sense right now, but it'll all come together. So I'll plug it in, and it's ready. So I'm going to press 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and minus. Once I've programmed in that last button, minus, the indicator LED on the right will stay on. So now it's programmed. There's another method of programming which we'll get to in just a second, but let's test it.
When we're in scanning mode, the PG jumper is disconnected, and we can connect jumpers to either A or B or both, depending on what mode you want to be in. If you place a jumper on the B header, that places us in active high latching mode. If we have that header disconnected, nothing shorting it, we are in momentary mode. So in which case A and B are not shorted, we are in momentary mode. If we've got both B and A connected, then we're in latching mode, but we are in active low latching mode. We'll discuss these all in just a second.
In order to test, you're going to want to remove the PG jumper with power taken off, and you're going to want to put it aside. Make sure none of the other jumpers are connected, and that will place us, except for the LED enable of course, that will place us in momentary mode. So I'm going to connect power again, and I'm going to press 0. And the 0 output on the pin block and the 0 LED will turn on for as long as I hold the button. So I'm letting go. 1, 2, 3, 4, 5, I'm going to do 5 again, 5, 6, 7, 8, and 9. So you can connect the corresponding outputs to your Arduino or other project, or you can connect the relay jumpers. Again, we'll get to the relays a little bit later. We're just going to test right now. And so we've tested all of the outputs except for our minus button. Our minus button only works in latching mode. How do we get to latching mode? I've removed power and I've connected a jumper to the B header. So right now the only headers that are connected are B and LED enable. So I'm going to power it up. Same codes are programmed in. 0, 1, 2, 3. So notice that they are all latching on. And if I press 0, 1, 2, 3 again, they turn off. So it's an on-off sequence. This is latching mode. So let's do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 7, 8, 9. Now I have two options here. I can press, if I want to reset all of the outputs to off, I can press the minus pin. Or, okay, let's do this again. 0, 1, 2, 3. Or I can press the cell button, which manually resets all of the outputs to 0. So what's the A jumper for, or the A header for? Now what I have on power up is a header, a jumper shorting A, a jumper shorting B, and a jumper shorting LED enabled. I'm going to plug it in. All the outputs go high, and this is active low mode. Most of you won't be using this mode, but it's an extra option. So all of the outputs are by default set to high. So if I press 0, it latches low. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I press the minus button, they all reset back to the default state. So with no jumpers on A and B, you're in momentary mode. That's the first mode we tested. If you have a jumper shorting B and not A, you're in active high mode, where all of the LEDs are by default off. All of the logic on the pins are low by default. If you have a jumper shorting B and A at the same time you power it up, you are in active high mode, or sorry, active low mode. And that's pretty much that. So let's go back into momentary mode and test our relays. What I've done is I have the LED enable header shorted, the R1 jumper shorted, and the B jumper shorted. So with the B jumper shorted, we're in latching mode. We're in active high latching mode. And we've got our relay 1, which is right here, this output. We've got that enabled. So when we enter the code that corresponds to output 9, LED 9, this relay will activate. Let's press it. The relay is on. The relay is off. So what if I connect a 2-pin jumper to R2? R2 corresponds to the 8th code. So the code that corresponds to output 8 and LED 8. So now R2 is on. Let's just press 9 again. And R1 is on. We can turn them off. Another thing that I can do is remove power, take my B header off, and I can go into momentary mode. I'll power it up, and let's press 8, which corresponds to R2. It's only on for as long as I hold the button. I'll let go now. And what about output 9? Or what about, R1? That corresponds to LED 9 and output 9. I'll let go, and there you have it. So that's the basic functionality. Let's talk about programming mode number 2. This one is a bit more complicated. I think some of you might find use in it. I would always stick to the first programming mode just because it's easier, but this allows you a little bit more flexibility. What I've got is the LED enable jumper connected and the PG jumper connected. No other jumpers are connected. And so what we're going to do is we're going to power it on, but the first thing we're going to do is we're going to make sure that while we're powering it on, we're holding down the cell button. You'll notice that the indicator LED will blink, and then it will stop. So then we let go of the button, we program in a code. I'm going to let go and program in 9. So I've programmed it in, the indicator LED told me so, and I'm going to hold down the cell button again. And I'm going to choose which output 9 corresponds to, including the reset codes. Anyway, it was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and reset. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, reset. So what I've done is I let go when output 0 was high. So now code 9 will correspond to output 0. So I'm going to press 8. 8 now corresponds to output 1. 7. 7 now corresponds to output 2. 6 now corresponds to output 3. 5 now corresponds to output 4. So I can keep going and program in all the different codes separately, including the reset code, but I'm not going to. What I'm going to do is I'm just going to remove power. I'm going to remove the PG jumper, and so now we're in momentary mode. The only jumper that's connected is the LED enable. 9, 8, 7, 6. Now you'll notice that because I didn't reprogram over the other codes, those codes are still saved. So 9 corresponds to output 0 and output 9 because we didn't re-record over those outputs. Before, this output was both the 9 button corresponded to this LED, this output 9. Now it corresponds to both 8 and 7. So 7 now corresponds to output 2 and output 7 because we didn't re-record over them. So you can actually use one button to activate more than one output. 6. There you go. In any case, if I wanted to, I could program in output 1, 2, 3, 4, 5 to, say, button 6 on the remote, and when I press button 6, all of them would either latch high or go high momentarily, depending on what mode of operation you're in. So let's go through it one more time. I'm going to program in some of these special buttons from output 5, 6, 7, 8, 9. So I've got the programming jumper connected, the LED enable jumper connected. I'm going to hold down the cell button. Good. I let go of the button. I'm going to press EQ. And I'm going to have that correspond to output 9. I'm going to press plus. I'm going to have that correspond to output 8. I'm going to press minus. I'm going to have that correspond to output 7. And I'm going to press CH plus to correspond to output 6. I'm going to remove power, remove the PG button to place us back into momentary mode, plug it back in. 9, 8, 7, 6, EQ, plus, minus, and CH plus. And there you have it. So I was able to program those codes in separately over 2 different program modes. I didn't have to program in all 11 at a time using the normal programming method. Again, I prefer the main program method, but this is a secondary option that will add some functionality to your projects. In any case, let's talk about the version 2 board. Sorry about the poor lighting in here. I'll try my best to go through it. Our 3 jumpers, A, B, and program, are right here. PG. We don't have the relay, so we don't use the R1 and R2 jumpers, and we don't have any LEDs, so we don't have an LED enable jumper. But we do have the cell button. So in order to test this, unless you're very fluent in the operation, we're going to need to connect an LED to this. How do we do it? What you need to do is get out a trusty breadboard, an LED, 470 ohm resistor, or really 300 to 600 ohms will be fine. I used a 3mm red LED. Connect the negative of the LED, the cathode, to the ground pin on the board, and connect the one side of the resistor to the CL pin, which is the indicator, the equivalent of the indicator output, just like the indicator LED on our other board. So I've got my programming jumper connected, PG jumper, and I'm just going to use this simplistic programming method, the first programming method. I'm just going to program in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and say minus. And the indicator LED is going to light up every time. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and minus. The LED will stay on. So now, what I'm going to do to test, I'm going to remove power. I'm going to take the programming jumper off, the PG jumper off, and I'm going to connect it to B. So we are now in latching mode. And I'm going to connect, say, I'm going to connect the positive or the secondary side of the 470 ohm resistor to output 0. And I'm going to power it back up. Now we're in latching mode. I press the 0 button. So the 0 corresponds to output 0 because that's what we programmed in. I'm going to connect to 1, output 1. If I press 1 on the remote, which we programmed it in for, the output will go high. I can press it again, output will go low. Output 2, high, I'll press it again, low, and so on. So we have verified at least a few of the outputs have been successfully programmed in. Now we can just connect those the relative outputs that you want to use into your Arduino, your TTL circuit, any 5-volt compatible circuit, and you'll be off to the races. The functionality is the exact same. A and B jumpers offer momentary mode, latching mode, active high, and active low. And what we can also do is unplug, and if we want, we can power our Arduino, power our unit with our Arduino. So let's do that. First thing you need to do after you've programmed in your board, you know it works, is you remove the EN jumper. So that protects the power supply and the regulator from back powering. And you take 2 wires, female to male. You connect one to the ground line on the version 2 board, connect it to one of the ground pins on the Arduino. You take another wire, doesn't matter what color, connect it to VCC, which is a regulated 5-volt line, connect it to the 5-volt pin on the Arduino, plug in your Arduino, and you've now powered the version 2 board. From there you can take another wire, say output 0, as many as you want, say you want to use specifically output 0, and connect that to IO 0 on the Arduino board. Your Arduino, when you plug it in, powers everything, and it's all tested. So hypothetically speaking, if I now press the button on the remote that corresponds to output 0, it will send that signal to your Arduino GPIO 0. Hopefully that makes sense.